All right, welcome back. So last video we were introduced to the quadratic formula, and we were told the wonderful truth that this can be used to solve any quadratic equation. All you have to do is make sure you know the formula and carefully fill in the A's, B's, and C's and carefully do the calculations, and you're going to be all set. That's nice. We looked at a couple examples. Now, moving forward, now that we know the quadratic equation, we can actually work backwards. In a situation like this, I could tell you that I have some solutions, and I could ask you to come up with the equation that has both of those solutions. Well, you have to work backwards in this case. So we know that if the solutions are minus 3 and minus 5, that means that x equals minus 3 or x equals minus 5. And now we can simply set these equal to 0. X plus 3 equals 0, x plus 5 equals 0. Now we can use our, I don't know if you remember this, but the zero factor property that we talked about last week. That means that if these things are both equal to 0, that means one or the other is actually equal to 0. So we can multiply them as factors of the greater equation, set that equal to 0, basically do a FOIL, first outside, inside, last. In this case, they did it in a slightly different order. It doesn't matter. Then you combine the like terms, and you end up with a quadratic equation. So we know that the quadratic equation x squared plus 8x plus 15 equals 0 has solutions minus 3 and minus 5 because we just worked backwards. So that's something that you now have the skill set to do. I'm not going to stress that too much, but it's nice to know. Okay, so moving back to... we're going to look at now what these quadratic equations look like in terms of graphing them. So remember our equation, minus b plus or minus the square root of b squared minus 4ac, I shouldn't use capitals there, over 2a. Right? This stuff that's under the radical sign, the radicand in this particular equation, is called the discriminant. Okay, it has a special term, and this discriminant is pretty important because it can be used to determine the number of real solutions to a quadratic equation. So you can very simply determine whether there's two real solutions, one real solution, or 0 real solutions, meaning that they're going to be imaginary numbers. Okay? So really simply, if you take that, and again, we turn this now into a function, so we've turned this into a graphical function. So y, or f of x, equals ax squared plus bx plus c. It's just meaning that now we're putting into that graphical terms, right, as a function. But if you look at the discriminant, if that discriminant is greater than 0, then it's going to have two distinct x-intercepts, or basically two real number solutions, because in this case, the x-intercepts are going to be the solutions. So, by the way, well, we'll see this in a second, but this shape is called a parabola. That's the graph of all quadratic equations are going to be parabolic shape. So they're either this U shape that opens upwards, or this, I don't know, upside down U that faces downwards. Okay? If the discriminant is greater than 0, it's going to have 2 times that it crosses the x-axis. Those are x-intercepts. And if it's equal to 0, the discriminant is equal to 0, you're going to have one x-intercept, meaning that it touches the x-axis at its minimum or maximum point, one real number solution. And, of course, if the discriminant is less than 0, that means there will be no x-intercept. That means our solutions are no real numbers, or basically that means the solutions are going to be imaginary numbers. You still will have x equals plus or minus something, but that's going to be like I times the square root of 2, or whatever that is. It's going to be an imaginary number. Okay, and that means that while you could graph the parabola for many things, you can't graph an actual solution for the x-intercept. Okay, one other aside, something else that we can do. We'll go back to graphing in a second. One other thing that we can do now that we have all these skills, basically our square root property, I could give you any crazy formula. Like, for example, the formula for the surface area of two spheres, which I don't know how often you use it. I don't use it very often, but I could give you any formula, and that is quadratic in nature. And you can use the skills that you have now to rearrange the equation to solve for a different variable. So I'm asking you to solve this for r. So basically rearrange this. So I want to get capital R isolated. Well, I got to get that coefficient out of there, so we divide both sides by 4 pi. Actually, I'm sorry, they're distributing first. Could do it either way, but they distribute the 4 pi first. Now I'm going to get this 4 pi r squared to the other side of the equation. 4 pi capital R squared is equal to all this. Now they're dividing by 4 pi, and you end up with r squared equals this whole thing, right? And we know how to solve for r now. This is the whole thing. We know this square root property. So you take the square root of both sides. That's going to be plus or minus all that stuff inside there, technically, okay? And r, although we know it's going to be a positive number, so that's why they don't include the negative, but mathematically you really need to. And anyway, then you can simplify this, and the last step that they've done is the square root of a over 4 pi plus the square root of 4 pi over r squared, and those 4 pi's in this case drop out of this one. Again, just showing you. It could be any equation, but you can use basic algebra to now solve for any variable, even in a formula that has squareds in it. That's all I'm showing you there. I'm not going to stress on that too much, but that's something you can do. One other thing that we can do, and we talked about this once before, but we can give you now this is a trinomial, but it's not technically a quadratic equation. Well, it's not an equation yet anyway, but we can turn this into a quadratic by substituting x in for our y squared term. So this is the same thing as y squared squared plus 3y squared, which is now we can make that y squared is going to be x. Substitute that in, and y squared is going to be x. So this is basically, again, this should not be squared here. This is simply x squared minus 3x minus 10, because y squared is our value for x. And then you basically, again, this is factored, and this you can factor this using you could factor this using any of the techniques that we know. You could factor this by grouping. You remember our A times C product, and they have to add up to B. So that would be minus 5 and plus 2. Rewrite that as x squared minus 5x plus 2x minus 10. Factor by grouping, you get this. And the last step would be you substitute in our y squared back in for y, and you go from there. I'm not going to stress that too much, but this is the words for that. And here's another example of that. And here's another example of that. Let me just, we don't need to know this. We don't really need to know this. We don't really need to stress about this too much. But just so you know, like, let's try this I'm not even gonna do the whole thing, but let x equal 2w plus 1. Right, that's all we're doing, which now this becomes 4x squared minus 16x plus 15 equals 0. You got me? And now this I can solve using any of my techniques. I could use completing the square, I could factor this, or I could use the quadratic formula. And once you're done, you're going to have x equals something, usually plus or minus something. Then all you have to do is make that something equal to 2w plus 1, solve for the w. So it's just an extra little bit of work after you've done the quadratic formula or whatever you chose to do to get here to solve then for the w. And actually you'll still have 2 solutions because you're generally going to have a plus or a minus situation there. I hope that makes sense. More importantly, because that is again not something that we're going to stress about too much, I just want you to be aware that it's something that you could and should be able to do, but I probably won't test you on it. Okay, let's look at graphing quadratic formulas or quadratic functions, because this is something that we want to understand. So again, standard form has a graph, and the graph is a parabola. Parabola is this U-like shape. By the way, these lines, they extend out forever, but they don't end up hitting an asymptote. They don't end up going straight at any point. They just keep going outward and upward forever. That's a really bad line, but that's the idea, okay? So I'm trying to cross that out. And the vertex is the lowest point on a parabola that opens upward, or the highest point on a parabola that opens downward. So it's your minimum or your maximum value for the y. So where am I at? So your vertex is either a minimum or it's a maximum. And remember, in this case, the discriminant on the graph on the right, the discriminant would be a negative, that b squared minus 4ac would have to be negative. And on this one, your discriminant would be a positive number. And that vertex, which is that point right here, has symmetry through this line, this blue dotted line, which is called the axis of symmetry. This dotted blue line is the axis of symmetry. And we already know that the sign of A determines whether it opens up or down. So this would be the sign would be a plus. What was I just talking about? I totally messed that up. Disregard what I just said about the discriminant. That's talking about the number of solutions. I'm sorry, I confused myself. Disregard this. Disregard this. The A term, I apologize, the A term, the plus or minus of the A determines whether this opens up or down. The discriminant determines whether there are 1 or 2 or 0 solutions on the x-axis. So in this case, the discriminant of this has, you notice, this has no x-intercepts, right? This means the discriminant would be a negative number on this one, and this one has 2 x-intercepts, so this one would have a discriminant equals positive. Sorry for confusing you. Okay. The axis of symmetry, that line that goes through the vertex, there's our vertex and the axis, which means that it's a mirror image on either sides of that axis. The line is a vertical line. That means it's a line at x equals something, right? It's the vertical line for every number where x is that number. And you can find that by taking minus b over 2a. That gives you your axis of symmetry always. So that's really nice. It's really, really important to understand and get this. So in an equation y equals x squared plus 2x minus 8, you get the vertical axis of symmetry by simply taking your minus b over 2 times a. So b is 2 and a is 1. Calculate that, and in this case you get your axis of symmetry at x equals minus 1. So on this graph, 1, 2, 3, your vertical axis of symmetry would be this line here. Your parabola would be opening upwards, something like that. Okay, so far so good. Axis of symmetry minus b over 2a. And the coordinates of the vertex can be found by basically taking that x coordinate and plugging it into your function and solving for y. That's all you do. You take that number, that line, your axis of symmetry line, you take that x equals blank number, you solve it for y, or f of minus b over 2a, and you end up with the actual point, which is the vertex. So now you know that from that last graph, the axis of symmetry was at minus 1, but the actual vertex was all the way down at minus 9. So that parabola would have opened up like that. And I'm going to run out of time for this video. I'm going to have to do one more quick video to complete the concepts of graphing these things. But so far we've covered the axis. We've covered the vertex. We've covered the line of symmetry, the axis of symmetry, and now we know how to actually find the vertex by taking your minus b over 2a and then plugging it into the actual line or the actual quadratic function, solving for the y value. That's the other point. That's the y value for your vertex. I hope that makes sense. We'll pick this up, and the next video will be a little bit shorter, and that'll pretty much wrap up the work for this week, and we'll go from some applications from there. Okay, one more video.